Okay, a lot of teachers actually, they kind of demand a lot of memorization, and there's a point to that. Like if you're in an environment where they're giving you exams and they expect you to go through questions very rapidly, like to give you 40, 50 questions, and you're allowed, like a minute to do a question, it gets tough. Memorization really does help. But I don't think that's the kind of skill you want to teach someone. A machine's good at that, but people aren't. What I'd be more concerned about is are you able to derive that, not memorize that like it's poetry, but are you able to derive this on your own? And the way I'm looking at it, I want to go through what I would do to do that, and that would be probably a substitution. All right. So looking at, let's go through that, and I probably would say, let x equal a tan theta. Abstraction though, right? Because I have the a as a parameter. And what's dx going to be? It's going to be a, that's some parameter, secant squared theta d theta. I'm ready for a plug-in. And let's write this down now. It's going to be 1 over. Well, what are you going to get? You're going to get a squared tan squared plus a squared. Now, that's not so bad. I can do that much. And what's the dx going to be? The dx is just going to be that a secant squared. I'll write this over here. I got that part covered. And I think I could probably do that. And let's put this down for you. So I'm seeing that what a squared pulls out from the bottom and a pulls out in the top. So that's 1 over a. And then you're left with secant squared on top. And on the bottom, what are you left off with? Tangent squared theta plus 1, which is also secant squared. D theta. And conditionally, they cancel. So let's put this over here. And what do you get there? Well, that's not so bad because the antiderivative over here. By the way, I forgot to put my star. It's going to be 1 over a times theta plus c. 1 over a. What's theta? Well, I'm looking at this over here. It's really x over a is the tangent of theta. So it's going to be the arc tangent of x over a plus some constant. We'll call it c now. Put a box on it. Did we show what they said we should show? We sure did. We got the 1 over a, we got the arc tangent of x over a, and we got the plus c. One is advertised. Thank you.